Hi everyone, Mrs. Oth here. I'm going to go ahead and run through some examples that are going to guide you through 6.6, especially 6.6 Practice A and Practice B. The first 6 questions that I go through here with you guys today is going to guide you on the front page of both Practice A and Practice B of 6.6. So what I have here to start off with is I have 7 raised to the x power equals 7 raised to the 4th power. When I have these bases being the exact same, and in this case my bases are 7, when they're the exact same, I can actually just cross them off, and then I just get x equals 4. So that's actually going to be my answer for this example, just x equals 4. Now the next example is going to be fairly similar, where I'm going to have the same bases, but I'm just going to have more math involved, more steps to solving. So I have 5 raised to the 2x equals 5 raised to the x minus 3. And again, those bases are the exact same. So these bases of 5, those are going to go. And now I have 2x equals x minus 3. And now from here, I'm just going to go ahead and solve. So I'll go ahead and subtract the x from each side. So now I just have a single x, so 1x equals negative 3. And that's going to be my answer. Now these examples are fairly easy because those bases are already the same. So as I continue on, we're going to have to change those bases. So this first example I have is 2 raised to the 3x equals 4 raised to the 6. Now this is the exponential unit, so I'm going to be creating exponents. So I'm always going to look at my larger base number and see if it's possible that I get this to be the same base as this one over here. So is there anything, so can I have 2 raised to a power that's going to equal 4? And the answer is 2 squared. 2 squared is the same value as 4, and now it will have the same base as the one on the other side. Now we can't forget that we started with a 6 here, so this 6 does drop down. So now the 4 squared is the value, the 2 squared is the value of 4, but now I have to multiply this 2 right here that I created by that 6. So now I'm going to have 2 raised to the 3x equals 2 raised to the 12th. And now my bases are the same. And now I'm going to continue just like I did for my first 2 examples, where I cross off those bases. And now I have 3x equals 12. I'll divide by 3 and now get my final answer of x equals 4. Now the next example I have for you, I'm going to have 3 raised to the x plus 5 equals 9 raised to the x plus 2. So again, we're kind of set up similar, where my bases are not the same. I'm going to look at my larger base and see, can I change this? And I want this 9 to turn into a base 3 because I have the base 3 over there. So 3 raised to what power is the value of 9? And it's going to be 3 squared. Now I have the x plus 2, so I need to drop that down. We have to remember that x plus 2 is traveling together, so I'm going to go ahead and trap it in parentheses. And I'll go ahead and drop everything down from the other side. So now my bases are the same, so I can cross them off. I'm going to have my x plus 5 right here. Now I'm going to go ahead and distribute this 2 as I drop it down. So I'll have 2 times x, which is 2x, 2 times 2, which is 4. And now I'm going to continue to solve for x. I'll subtract x from this side. So 5 equals x plus 4. And then I'll subtract the 4 over. And finally, I'm going to get x equals a positive 1. All right, let's go ahead and move on to another example. This next example is going to be a double base change. So if you can't change one of the bases to get to the other one, then we might have to change both of the bases. So I'm going to have 4 raised to the x minus 3 equals 8 raised to the 2x minus 1. Now ultimately we want to see if we can get this bigger base to be the base on the other side. But I know that 4 raised to the second power, that would be the smallest thing I could change it to, is 16. That's not 8. So when something like that happens, then we have to look at what we call a double base change, where both the 4 and the 8 are going to change. So 4 can really only change to 2 squared. Since 4 is a very small number, it doesn't have very many options. And then if I look at the 8, I know that 2 raised to the third power is going to be 8. So now my bases have changed to 2 squared and 3 squared, which is still the value of 4 and 8. But now I need to drop down the existing exponents that were already there. And since my bases are the same, they go. And now I'm going to go ahead and distribute and solve. So I'll have 2x minus 6 equals 6x minus 3. Go ahead and subtract the x over there. Now I'll add the 3 over. And finally, I'm going to divide by 4. So I'll have x equals a negative 3/4. All right, so the last type of solving exponential question on those first pages of practice A and B that you're going to see is something like this, where I have that 1/27th. And I'm going to go ahead and change that 1/27th right away. What we have to remember is that if I had 27 raised to the negative 1, I can change that into a fraction of 1/27th, and it gets rid of that negative exponent. What I'm going to do, since I start with that 1/27th, I'm going to now change it into that negative exponent so I can get rid of that fraction. So I'm going to change again this 1/27th to 27 raised to the negative 1. And it already has its existing exponents of the x minus 4. I'm not going to change anything to the other side quite yet. Now I'll go ahead and distribute this right here, that negative, into the x and the minus 4. Okay, so now I have a 27 raised to negative x plus 4 and 3 raised to the negative x. Now I'm going to go ahead and change the 27 to get it to be a base 3 because I have a 3 over here. So 3 raised to the third power is 27. And now I'll go ahead and drop the negative x plus 4 down. And over here, again, I'm going to keep my 3 raised to the negative x. At this point, I have the same exact bases, so I'm going to cross off my 3's. I have a negative x equals a negative 3x plus 12. And I'm going to go ahead and complete solving for x. So I'm going to add 3x to each side. So now I have 2x equals 12. And when I divide by that 2, I'm going to end up with x equals 6. So the next 4 examples that I go over are going to be the backside to 6.6 practice A and practice B. Just like before when we were dealing with the exponentials and we were crossing off things that were the same when they were on different sides of the equal signs, we're going to go ahead and continue with that. So you'll see that I have a log base 3 here and then a log base 3 here on the other side of the equal sign. And since I have nothing in front of them and the bases are the same, it's really important that these 3's are the exact same. And when you have that, you can go ahead and cross off these log base 3's, and then you're just left with an equation to solve. So we're going to have here an x plus 3, because that drops down, equals the 2x plus 1, because this drops down. And now we're going to go ahead and just continue to solve for x. So I'll subtract x from each side. Then I have 3 equals x plus 1, and I'll go ahead and subtract the 1. So I'll end up with an x equals 2. The next example that I have is going to be very similar, but instead of having the log, it's going to have an ln, the ln representing natural log. So the exact same equation. If I have the ln equals the x plus 3, ln x plus 3 equals the ln of 2x plus 1, we're actually going to have the exact same answers. We have the ln, the natural log, on each side. I cross that off and I get x plus 3 equals 2x plus 1. So the exact same equation that we just did. So it doesn't matter if it's a log or a natural log, we're going to do the same thing. The last thing you're going to be asked to do on your handout is to take the log and move it into exponential form and then go ahead and solve. So we need to understand and remember what the log turned into the exponential looks like. So right here I have my log form. This is going to turn into 4 raised to the third power equals x plus 2. And what I'm going to do is I'm just going to calculate the 4 raised to the third power, which is 64. So I'll have 64 equals x plus 2, and then go ahead and continue to solve for x. So I'll subtract 2 from each side, and I'll get x equals 62. I'm going to go ahead and give you guys one more example that's very similar to that, but then we're going to actually have to incorporate our change of base. So I have the log base 3 of 9 equals x minus 1. So step 1 is to move that into the exponential. So I'll have 3 raised to the x minus 1 equals 9. Now from here, when I solve, I need to now change the 9 to be a base 3. So this 9 is going to turn into 3 squared. And over here, I'll still have my 3 raised to the x minus 1. And now since those bases are the same, I'm going to cross them off and continue to solve. So now I have x minus 1 equals 2. I'll add 1 to each side, and I'll get x equals 3.